So welcome everyone. Yesterday we have discussed regarding installations and a few of the details regarding configurations and running few of the Hadoop monitoring tool. Like we have discussed about the overview about Ganglia Nagios, and so today we have first need to go through the installation configurations and running options of Ganglia monitoring tool. Pretty much we have discussed about the three different configuration kind of components of Ganglia, like the monitoring daemon, Ganglia meta daemon, and Ganglia web interfaces. So today we'll be first seeing the we'll first go through the hands-on of installations of Ganglia, deployment of Ganglia on Hadoop cluster. Then we would need to go through the configuration options of Ganglia. We just need to go through the configuration steps of the different host that needs to be done on Ganglia tool, and just need to set up the Ganglia services that we need to just go through over there. And apart from that, we would also need to go through the installation and configurations of Nagios. That's Nagios version 4 that we need to be work on so far. And typically to work with Nagios, we basically need two different servers. That's Nagios server and Nagios client. So we would be just go through clone of the systems of the Hadoop cluster, single node Hadoop cluster, so that one cluster could be utilized as a server, one cluster could be utilized as a client. So the Nagios installations and plugins, that is also equally important, similar like Ganglia. Once it has been done so far, next, we need to go through quick hands-on on protecting the enterprise data with HDFS snapshots. That's HDFS data recovery and backup. Typically for enterprise Hadoop clusters, we just need to take up the backups and snapshots that need to be taken through the substrate of the file systems and the inter-file systems, so that the snapshot that should be as permanent and reliable, and it should be scalable as well. So we just need to go through the steps that how to enable the snapshots over HTTP Hortonworks HTTP cluster. And for the snapshot creations, I will basically go through few of the basic levels discussions regarding the high-level requirements, high-level approaches for creating the snapshots, and for basically for creating the snapshots for enterprise Hadoop clusters and HDFS. And then there are a few things that we should just need to know regarding name node high availability configurations for automatic failover that we need to go through, and similarly just few steps on automatic decommissioning of data nodes and dark structures. So these are the things that still left, and at the end our last module that could be based on the configurations of Kerberos on Hadoop cluster. So let's go through the today's first lesson. That's installations of Ganglia. So what I have already discussed about Ganglia, that Ganglia it's a real-time distributed monitoring tool which helps to collect the information from each node in the Hadoop cluster, and it helps to provide an interactive way to view the performance of nodes and clusters for a whole. So it also helps to provide the multi-mode insights for monitoring reports on hourly, daily, weekly, monthly, and yearly basis. So we have already seen Ganglia on an enterprise Hadoop Hortonworks cluster. While we have been provisioning through it Ambry, and on the Ambry portal we could be able to view the Ganglia as well. And we have already discussed the three main components of Ganglia, that's Gmon, Gmetad, and Ganglia web frontend. So Gmon, just once again as a quick recap, it's a Ganglia's monitoring daemon that's which helps to collect the monitoring data from the nodes and sends them to the configuring host. So it is configurable to send the monitoring data so as many hosts as you want, and it also has a functionality to receive the monitoring data from other Gmon daemons. Here comes next the Ganglia meta daemon, that's the Gmetad, which gathers the matrices from Gmon nodes that sends the monitoring data and writes them into the round-robin databases. So Ganglia typically uses this round-robin databases, RRD databases, to store the monitoring data, and it is configurable to collect the monitoring data from any numbers of clusters. And we have also gone through the Ganglia web interfaces. Typically, as we have discussed, the Ganglia web interface, that's having gone through that web interface that presents the monitors the data in graphical form for clusters, as well as typically in the node level. And as the cluster level, it shows aggregated graphs like for CPU, memory, network, and disk. And at the node level, it shows the aggregated graphs of standard system matrices, and additionally it also helps to show the individual graphs for the systems as well as technology specific matrices. So Typically, the first step for the installations of the Ganglia, like in Ganglia, the Gmetad and Ganglia web app that should be installed on the same node, because the Ganglia web app uses the RRD data, which gets generated only on the Gmetad node. That's a Ganglia metademon node. So you also need to choose that one daemon, one Gmon head node, that where it could be configured as sender and receiver to be both. So in the below, in this proposed solution that we will be going through in the installation and configurations, we will be considering the Gmod installation that's to be done, and on the same node where the Ganglia meta monitoring services, meta demons, and Ganglia web app is to be installed. The reason for choosing the single node sandboxes, single node cluster, is because both sender and receiver is to minimize the configuration complexity. If we go for configuring each Ganglia monitoring daemon node as both a sender and receiver, in that case we need to configure all the nodes in Ganglia meta daemon services configuration file. So in order to just minimize the complexity, so we just need to configure only the one node as sender and receiver, and the remaining nodes as to be, it can be as a sender only as to send the matrices data or to the head Gmon node. So basically we just need few commands to install the Ganglia monitor, Ganglia metademon services, RRD tool, and Ganglia web frontend on the head node. So the first command we need for the installation is Ganglia monitor, RRD tool, Gmetad, and Ganglia web frontend. So typically the Ganglia web frontend package also installs the required Apache server and PHP modules. The Ganglia web frontend installation typically generates few files that could be named as that could be done as if you just choose on the Ganglia web frontend installation, that could generate a file that could be called as apache.conf. This configuration file would contain an alias for /ganglia URL that could be pointing to the location user share Ganglia web frontend PHP application. So in order to run Ganglia on Apache web server, it's required that you should copy the etc/etc/ganglia web frontend/apache conf file to the etc/apache2/sites enable folder by using the next command that you will be using. Just we need to copy the file. Okay, so the next step is to copy the Apache conf file. And on the other nodes, if you have, so there you just need to install the below, the command to install the Ganglia monitor. So in the other nodes, suppose you have the separate nodes that one server you want to utilize as Ganglia server, and another server you want to install as for client, Ganglia client. So in the client server, you can install the Ganglia monitor as well. So simple command that we need to go for, that sudo apt-get install Ganglia monitor. For this demo, I'm installing in the same cluster. So the steps that I have been configuring here, the first step, one, it was installation of Ganglia, where I just installed the Ganglia monitor. I've installed Ganglia monitor, gmetad, rrd tool, and Ganglia web frontend. Ganglia web frontend on the head node. So if you are configuring on master and slave node, so on the master node you just need to configure this following services. In the next step, the Ganglia web frontend package that could also install the Apache server and PHP module, so for the front-end configuration purpose, and the entire Ganglia web front-end installation file that being generated for this step after this, that will be present in this directory, that etc Ganglia web frontend / Apache conf, and this file we need to be shared with etc / Apache 2 / sites enabled / Ganglia conf. So that's we did for this following steps. Let me rename it like this. And in the third step, for the slave nodes, like for the other nodes or the slave nodes, there which node you want to utilize as a client. So there, Ganglia client node, you just need to install sudo apt-get install Ganglia monitor. You just need to install the Ganglia monitor tools. So that was the first step. In the second step, to go for configuration of Ganglia. And in configuration of Ganglia, there are two ways to configure Ganglia. Either is unicast or in multicast. So the main differences between both of them is that the unicast uses a specific host address for sending and receiving the matrices, and the multicast one that uses the multicast addresses. But in both modes of configuration, Ganglia monitor can be configured as a sender or receiver, or both at a time. So Ganglia typically contains two configuration files. As we know, one is the gmetad.conf, which is used for Ganglia metadaemon service, and another is gmont.conf, which is used for Ganglia monitor daemon services. And the default location for both of the configuration file is present within this directory, that etc/Ganglia. That's default for any types of cluster. Now, in order to configure the gmont, so gmont could be configured by updating the cluster section, UDP send section, and UDP receiving section. So it could be configured by updating cluster section UDP send section UDP receive section in the Gmon configuration file. So let's see that what is the configuration process and how to take an example of a cluster of 2 nodes. So in this example I have in this demo I have just a single node, but suppose if I'm having the a multi cluster node, I have one master node, one slave nodes together. So I have 2 different hosts. Suppose host 1, which is the head node, and host 2, which is the Gmon node only, that's Ganglia metademon tools, that means the Ganglia monitor daemon services. So we just, in that cases, we just need to configure the Gmon configuration file for host 1. So in that cases, what we need to do, we just need to open this file, Gmon configuration file, etc Ganglia. So this is the configuration tool that we need to take care of, that we need to configure the Gmon configuration file. So suppose for the first host, like in the head node, the configuration that we need to do, the first one defines the globals, and in the global sections we have demonize, so the value should be yes. Set ID, that should be value as yes. User is being defined as nobody, but here you can set the name of Ganglia user. So there you can set the name of your Ganglia user or the username of the cluster. And the next, all the schemas like debug level, that should be equals to 0. Max UDP message length, that could be equals to 1472. Mute equals to no. Def equals to no. Then host demax equals to 0, that's for second. Allow extra data, that could be equals to yes. Cleanup threshold equals to 300, that would be in second. GXAC, that could be the value should be no. Send metadata interval should be, you could configure it as 30. In the next one, next attribute, like if a cluster attribute is specified, then all the Gmon hosts are wrapped inside the cluster tag. So if you do not specify a cluster tag, then all the hosts will not be wrapped inside the cluster tag. So in this function, you need to configure the following schemas. The cluster name, which is made as unspecified, just need to give the name of the cluster. Just need to give the name of the owner, that's a cluster owner. So I'm just giving the values regarding for this cluster. Next, you just need to give the lat long values. So lat long values, you can make it as unspecified. URL, that could be also unspecified. Next, in the section, the host, that section that describes the attributes of the host, like the location. So in that cases, location it could be made as unspecified. For the UDP send channel, that for many UDP send channels, like you just could add. For multicast join, you can specify the port number as 8641, and also just can set up IP address. So you just need to set up the host, the port number, and TTL. Default TTL would be 1. And in the receive channel, just I need to specify the port. No need to give the host once again. And in the TCP accept channel, just make the port number 8649. So that's the configuration we just need to make in the head node. Suppose host 1 where the Gmon service is running, we just can make the configurations as like this. So specifically just need to make changes in UDP send channel, UDP receive channel and TCP accept channel. So check the port number 8649. UDP send channel, specify the cluster address, that's a multicast join, or what you can do, you can mention it specifically as host in the UDP send channel and just give the IP address aliases for this cluster. That's all. You can save and exit. Next, you just can configure the Gmon configuration file in the next in another cluster. Suppose you have a slave node that's being running, suppose as a host 2. So there also you just need to configure the same way. You just need to configure the file, the gmon.conf file on the host 2 cluster. So pretty much would be the same configurations and the same configurations would be there. Only in the gmon.conf file for the slave node, just need to make sure the cluster name, the host address of the head node in the TCP UDP send channel, just for things that we need to change off, and the port in UDP receive channel and port in TCP accept channel. So suppose the similar change if we need to do for slave node, in gmon.conf file. So these are the parameters that we need to just change. That's cluster name, host address of the head Gmon node in the UDP send channel, number C, the port in UDP receive channel, and number D, the port TCP accept channel. So the UDP receive channel, that should be only be the on the head node, because all the other nodes send matrices data that would be sent to this node. The next step is the configuration of the gmetad. Configuration of Ganglia metadaemon services. So the Ganglia metadaemon file, that could be configured by providing the inputs in the data source code section, and we just need to provide the following inputs in the sample code. Like we just need to provide cluster name, then polling interval, then host name of head node with gmon port. These are the specific details we just need to provide, and there are many other parameters like RRD directory location, grid names, etc. that we need to configure them based on the custom requirements, but the default configuration, that should be also working fine. So here comes the configuration file of gmetad, that's Ganglia metadaemon services. Here you just need to make sure the following parameters are being there. Data source would be specified by the name of the cluster, and next you just need to provide this following settings, and the next line the username. Just I've given the username for the sandbox. So as many as other requirements, like other parameters like RRD directory location, the grid names, RRD grid names, etc. So that you can configure based on the specific requirements you have that you need to set up. But these are the default settings that you need to configure in the Ganglia metadaemon services configuration file. Next step is to creating the RRD directory. So typically, to create the RRD directory, Ganglia uses typically the round-robin database files to store the data. So you just need to create the RRD directory on gmetad node. The default locations of RRD directory that could be located in this location, that var lib Ganglia RRDS. This is the default locations of RRD directory, but you can configure it as per as your requirement specific. So what you need to do, we just need to create the specific command to create the RRD directory and to change the owner to the specific user that what we have, and it should be ensured that the same user has to be present in both gmont and gmetad configuration file as well. So let's go ahead. We've created the directory. The next step is to provide the permission. So we have created the RRD directory and we have provided the permission as well. The third step is to running the Ganglia services. Step 3. Running Ganglia. So there are two services called gmont and gmetad. So there are some of the commands are available to start the gmetad and gmont services. Typically, sudo service gmetad start and sudo service Ganglia monitor start are typically the commands where Ganglia monitoring services that could be installed and could be started. So just we need to execute the following commands. Sudo service Okay, so all the services has been started. So once you have done all the installations and configurations, so you just can access through the Ganglia through the following URL, that's http clusterhost/Ganglia URL. So once you open up a URL, the cluster monitoring page would be shown up, and if Ganglia has been configured, suppose with multiple clusters, so all of them that should be shown in the grid view. And if you scroll down to view all the clusters one by one, so selecting the cluster that could through the source drop down view, that could be very specific monitoring in detail. Cluster monitoring, that should display the overview of the cluster, that's graphically, and it could be easy to understand, to visually represent as to be all the specific monitoring matrices that could be visible over here. So Ganglia is typically as a monitoring tool, it's being pretty available for Apache Hadoop based clusters. If you specify for any vendor specific Hadoop clusters, like for Cloudera, for Hortonworks, for Mapper, they have typically their specific cloud, the monitoring tools that's being available. Like for Cloudera, CDH Hadoop distribution, we utilize a Cloudera manager as the monitoring tool. For Hortonworks, typically we use Ganglia, that's utilizing on Ambry. For Mapper, we have typically M5 as for the administration portals and for configuration tool. So it depends on, again, the requirement, like what kind of Hadoop monitoring tool that could be utilized for a production cluster. So typically for till now, for enterprise Apache Hadoop clusters, Ganglia, Nagios, Zabbix, these are the specific tools that could be utilized for monitoring troubleshooting purposes. So the node level view, if we check after installations of the Ganglia in the Hadoop cluster, we'd be able to see that the graphs and matrices that would be shown up, that could be consist of the constant matrices such as RAM, CPU speed, CPU bound, total swap spaces. It should also consist of the aggregated graphs for CPU, memory, disk, packets, like this. And also it could be showing up the individual graphs for CPU, memory, disk, network, pressure matrices, like this. So you have already seen that during Hortonworks installations and in Hortonworks Ambry portal. So that was pretty much about Ganglia installation and configuration. In the next step, what you need to do is basically you need to go through the installations and configurations of Nagios 4 on this cluster. So Nagios is, again, as we discussed, is an open source software that could be utilized for network infrastructure and for monitoring purposes. So Nagios typically helps to monitor the servers, switch, application services. It typically alerts the system administrators that when something goes wrong, and also it just alerts back when issues have been rectified. So what is the utility for Nagios? Just a quick recap. So Nagios helps to monitor the entire IT infrastructure, to identify typical problems, typical issues for troubleshooting cases, to know immediately when problem arises by alerting services, and it helps to share availability data with stakeholders. It helps to detect the security breaches. Number 6, it helps to plan and budget IT upgrades. Number 7, it helps to reduce downtime and business losses. So these are the pretty much about utility of Nagios. And typically in the Nagios we typically use two systems. One could be utilized as Nagios server, and another one that could be the Nagios client. So make sure that the server that you are going to install on the Nagios server, that should have a fully working LAMP stack. So if not, so you just need to install explicitly the LAMP stack on the server. That's typically the server that could be utilized as Nagios server. And once the LAMP server is being working fine, so in that cases you are good to go with installations of Nagios. And also you just need to install some other prerequisites as well. So for that purpose, I'm using a Hadoop master daemon. So let me power off this guy. So let me quickly install LAMP server here. Next, to install MySQL. Okay, Apache LAMP server is being installed, and so the next step for starting the Nagios server, just need to do the next steps of configuration. So in the Nagios server, just now we have just installed the working LAMP stack, and we have installed PHP MyAdmin, MySQL, Apache 2 configurations over there. And once the LAMP stack has been working, next step we just need to add some additional prerequisites as well before go ahead and install Nagios. Let's sudo apt-get install build essential lib gd2 xpm fin dev apache 2 utils. So after configurations and installations of LAMP on the server, we just need to install this another prerequisite before go ahead and create the Nagios user and group. So next step is to create a new Nagios user account and give it to a password. So just create a new user for Nagios. Sorry, first create a group. Then set the user mode. naxamd Nagios. Okay, start the user. And user name. Set a password for Nagios user. Just given the password. I've already created the group. Next, just give the permission. So next step, we need to download the Nagios and the plugins. So what we have done so far, the first step for the installations of Nagios, step 1, in cluster, specifically Nagios server cluster. Make sure full LAMP server stack is installed and configured, and also just add and install the next prerequisite, that build essential library gd2 xpm dev apache utils. Install apache utils package. Step 2 is add Nagios user and group Just need to give the create the user for Nagios and set up the password, add the group for NAGCMD, add the set up the user mode permissions for Nagios and www data, that's Apache cluster. um, so both for Nagios user and the Apache user to the group just need to give the permission. And step 3 is download Nagios and its plugins, and 4th step is the configuration. So let's move back. So we can download Nagios from its downloading page. So what I will do, move to downloads, and I can download Nagios. It's pretty small. So it's downloaded. The next step is to extract it. So it's extracted. Just execute the following set of commands. So configuration has been successful, and Nagios configurations has been done. Next step, just need to make it sudo make all. Yeah, it meant. So just executed sudo make install. Next step, sudo make install init script installed. Next, sudo make install config files are being installed. Next, sudo make install command mode. So external command directory is configured. So in the next step, we need to install Nagios web interface. So to install Nagios web interface, we just need to execute sudo make install webconf. So it would compile and install Nagios web interface. So this is the error, that's fine. So this above error message that describes that the Nagios is trying to create the nagios.conf file inside the etc/httpd conf directory, but in Ubuntu the Nagios conf file that should be placed inside the etc/apache2/sites enabled directory, the same directory that where you have pushed the Ganglia web component as well. So we just need to write the following command: sudo user bin install cm sample config httpd conf /etc/apache2 sites enabled nagios.conf. So this command, the earlier command, that could work well if you're working on RHEL or CentOS or Fedora, but if you're working on Ubuntu or Debian or Wheezy, so we just need to make sure that we just need to add this next command as well, what executed. So just need to make sure the Nagios conf has been placed inside the etc apache2/sites enabled directory or not. So just need to make sure. So it's being placed. Now next, create a Nagios admin account for login into a Nagios web interface, and just remember that the password for that we should be assigning for this admin account, we just need it while logging into the Nagios web interface. So just need to write user local Nagios ht password users Nagios admin. Oops. So we have added the new password. Next step, just restart the Apache 2 service. The next step, just need to go to the directory where we have downloaded the Nagios plugins. So just come out. So we have not downloaded till yet Nagios plugins. So we just need to download it. We just downloaded Nagios but not plugins. So let's download. Am I audible, guys? Okay, so we have downloaded Nagios plugin. So let's go ahead and install Nagios plugin as well. Sudo tar Nagios plugins 2.0.3 tar.gz. Sorry. Let's move inside Nagios plugins folder. Now next we need to run the set of commands one by one to compile and install Nagios plugins as well. So just need to run sudo configure it's compiled with make. Okay, next step is the configurations of Nagios. So Nagios sample configuration files. Now it has been installed in the user local Nagios slash etc directory. The sample file should work fine for getting started with Nagios, but however, we just need to put the administrator's email ID to receive the alerts as well. The same thing, if you could remember, like while we are installing Hortonworks HDP cluster with Ambari, during Nagios configuration page, we just got a warning that regarding that the Nagios database configurations, and also we need to set up the administrator's email ID to set up the alert monitoring system, so that Nagios could be checking up and sending the corresponding emails, just like as a churn analytics. It could send us the email digest over time to time. Based on the monitoring interval time, it could send us the emails regarding the system's alerts and monitoring details. So to do that, basically to receive these actual emails for the alert monitoring purpose, we need to edit this user local nagios slash etc slash object slash contacts of cfg config file with any editor, and then we need to change the email ID, email address or associated with the nagios admin contact definition to the address that wherever you just like to receive the alerts from your cluster. So what you need to do next, so this is the page where you could be able to see that you should have the following options for contacts. That's the contact definition, that's by default the Nagios admin. So here the contact name, as you can see, the Nagios admin name that's been given, and the user that inherit, basically it's the short name of the user, so keep it Nagios admin. Inherit default values from generic contact template, so that you can give any specific names. The alias could be the Nagios admin. Email specifically we need to change. So you just need to change this with your valid email ID, system admin's ID. So I'm just giving a working email ID. Once you have done, save and exit. Then we need to edit another file. That's Nagios conf file. Here we need to edit the same set of lines if you want to access the Nagios administrative console from a specific particular IP address. So here suppose I want to allow Nagios administrative access from a specific IP address. Oops. Instead of localhost, I can make it to any other system. So I'm making it to another Linux server that I would be able to access it to. Similarly, if you want to access it from any other system, so you could be able to access, just need to give the IP address for that system. And next step, we need to enable the Apache's rewrite and CGI models. Okay, both of the services Apache Rewrite and CGI modules have been enabled. Now next you can check in Nagios conf file for if there is any syntax errors. Nagios bin user local Nagios tc nagios.cfg. So is everything is running fine? There is no errors, no warnings. That means the service has been running fine. So next we can go ahead and start the Nagios service and make it to start automatically on every boot. Okay, Nagios service has been started. To make it automatic started on each and every booting time, just made the simple configuration. rcs.d/99. Okay, so that's all. And if you need to want to access Nagios, so what you need to do, just need to go ahead with your browser and just need to write HTTP your Nagios server IP and /Nagios. You just need to write, and there you just need to log in, enter the username as Nagios admin and password whatever you have provided during the password creation steps. That password just need to enter, and then we'll be able to see the Nagios administrative console that should be look up. And on the particular host, we should be also able to see the more details like specific modules, monitoring targets to the Nagios server. That specific details will be available. Now if you want to add the monitoring targets, specific monitoring targets to the Nagios server, to do that we need to install NRP and Nagios plugin as well to our monitoring targets. So in that cases just need to make some more configuration. If you are working on CentOS or RHEL, so just make sure that you have to install EPL release first, and if you are working on Ubuntu, just go ahead and directly install sudo apt-get install Nagios NRPE server Nagios plugins. So this one is typically to add a monitoring target to specifically to the Nagios server. Once it has been installed, next we just need to configure the monitoring targets. Next, just configure the monitoring target. So we just need to edit tc Nagios nrp.cfg file, And here just add your Nagios server IP address. Just find the server address. Okay, that's all. Now, if you are working on CentOS or RHEL, you just need to start the NRP services by using systemctl start NRP and check config NRP on. If you are working, suppose, on CentOS 6, and in that case, you just need to execute service NRP start with check config NRP on. For Ubuntu, you just need to execute the following command: initd Nagios NRP server start. Now you can go back to the Nagios server, and to do that, you just need to edit the Nagios CFG file. User local Nagios, and here you just need to uncomment the following lines: CFG dir. So CFG files, CFG dir, whichever is mentioned as user local Nagios etc servers. Just we need to uncomment this line. Save and exit. Next, create a directory called servers under user local Nagios etc/servers, and create a config file to the client that needs to be monitored. So just open it with Vim or any other standard editor. User local Nagios etc servers clients dot cfg, and here just add some set of lines. Define host, then write use. Use of course would be for Linux server, then the host name, so I've given here my host name, then give the alias, that could be the client host name, the client name, and give the address. So let's give the address of this cluster 133. Give the alias max check attempts, the value of 5. Give check period, 24/7. Notification interval, this could be 30, and notification period be 24/7. So once this has been given, you can save and exit. So here in this IP address, you just need to give the client IP address. So instead of the server, just replace it with the client IP. Then you just need to restart the Nagios service, sudo service Nagios restart. Just wait for a few seconds, and we'll be able to see next in few minutes that the Nagios services would be started. So in this way, we would be able to define the more and more clients by creating a separate config files within user local nagios/etc/servers directory for each and every client. And if you just want to define the monitoring host, like if you want to add some more services of the monitoring host, so in that cases, for example, like to monitor the SSH services, we just need to add some few lines in user local nagios/etc/servers/clients.cfg file, the same file that we have been working, and we just need to add the addresses, just replace the address with the client IP addresses, and just need to add some services as well. The services that what you need to add, let's open the file. So here, just the services that we have added, here we just need to add some set of services like define service, like this way. Define service, use some generic service, host name, that should be the client, then service description, that of course would be SSH, check command, could be check SSH, and notifications enabled could be equals to 0, and next you just need to close it and save and exit. So in that case, again, you just need to restart the Nagios services once again. So this is the way that we just need to install, configure Nagios in real time. We just need to have two different cluster. One would be your production cluster that could be worked as Nagios server. Another one could be the monitoring cluster that could be utilized as Nagios client. And after installation, after making the configuration so far, you're just also able to add the monitoring targets to the Nagios server. So you can just add some specific clients to monitor the Nagios server itself. So to do that, we just need to install the NRP and Nagios plugins specifically in the monitoring target. So that functionality typically we do in the separate cluster, that's in the monitoring clusters itself. And after installations of Nagios plugin in the monitoring cluster, we just need to make sure that we need to configure the monitoring targets, and in order to configure monitoring target, we need to edit the nrp.cfg file that's present within etc/nagios directory. There we just need to add the nagios server IP address, that's the nagios server. And if you're working on CentOS, RHEL, or Fedora, so on, anything specific to the Red Hat foundations, so there we just need to specifically add specific command, like you need to execute systemctl start nrp with check config nrp on if you are working on CentOS or Red Hat 7. If you are working on CentOS or Red Hat 6, so just need to make sure that service nrp start and check config nrp on commands have been worked. If you're working on Debian or Ubuntu or Visi, so that is fine. You just need to make sure that nagios nrp server restart command is to be working. And after that, need to configure the nagios CFG file, and there just make sure that just need to uncomment the line that's configuration directory of nagios servers. Next, create the server for nagios that could be utilized for monitoring purposes, and create the config file that needs to be also monitored, that's client.cfg, that this one. And here just make sure that you just mention the client IP address, and once you mention the client IP address, just restart the nagios service. And also you could be able to define some of the services. So defining, that's typically for monitoring the host. So if you want to add some more services of the monitoring host, for example like monitoring the SSH service, in that cases you just need to add the following lines, whatever I've defined as a service. Like as defined host, use the Linux server, host name, alias, address, max check attempts, check period, notification interval, notification period, that's the first one. And second one, for defining service, just need to add use, that's your generic services, whatever you want to utilize. Host name, that could be your host name. Service description could be SSH, that's the service if you want to monitor. Check command, that's check SSH, and notifications enabled. So just save and exit, close the file, and then just need to make sure that your nagios services could be restarted once again. Now if you are trying to use the check HTTP with -s flags for HTTPS cases, so in that cases that just need to make sure that whenever you are working on configuring the nagios plugin, so in that cases you just need to add hyphen with OpenSSL. So suppose if you are trying to check HTTP with ACE, that means you are trying to check with checking the HTTPS flags. So in that cases, make sure that you have installed OpenSSL and libSSL, library SSL dev first. And yes, of course your nagios server would be checking a remote client, so you just need OpenSSL and library SSL dev locally. And then what you need to do, you just need to configure nagios plugins with OpenSSL parameters. So just need to check up with this command, configure with nagios user, nagios with nagios group equals to nagios with OpenSSL. So that's all. That's all about the configurations of nagios installations and configurations in a real production Hadoop cluster. So the next demo, that we are being able to check is typically on HDFS snapshots, that's protecting your enterprise data with Hortonworks HTTP snapshots. So typically whenever we need to go ahead with enterprise clusters and we need to protect the data over HDFS, and we just need to make sure that we need to make some snapshots. So there is in HTTP 2.0 onwards, we have even in HTTP earlier versions, that's 1.3, 1.4 onwards, there is a facility to create the snapshots to protect the important enterprise data from the users or application errors. So HDFS snapshots are typically some read-only point-in-time copies of the file system, and snapshots that could be taken on the subtree of the file systems or the entire file system. So just we need to make sure that whenever we are taking up HDFS file systems, HDFS snapshots, HDFS snapshots. So number one, it should be performant and reliable. That snapshot creation is typically, it could be atomic and instantaneous process, so no matter the size or the depth of the directory subtree. And number two, it should be scalable enough so that snapshots do not need to create any extra copies or blocks on the file system. Snapshots would be highly optimized in memory, and that could be stored along with the name nodes file system namespace. So typically, as a features of snapshot, snapshot is typically as a functionality, it's a point-in-time image of the entire file systems or the subtree of a file system. And some of the scenarios, the snapshots are really useful in real-time administration purpose. Like number one, in case of protection against user errors, like where admins needs to set up a process to take read-only snapshots periodically in the rolling manner, so that there are always the numbers of RO snapshots being available on HDFS. And if suppose if user accidentally they just deletes a file, so the file could be restored from the latest RO snapshot that would contain this file. Number B, it should be utilized for backup purpose. Because if suppose admin wants to take the backup of the entire file system, so the subtree in the file system or just a file, it could be there. So depending on the requirements, admin can take either a read-only, just an RO snapshot, or hence it could be utilizes this snapshot as a starting point or a full backup. So incremental backups could be then taken by doing a difference between the two snapshots. Next one is for experimental test or setups. So in that cases, suppose a user wants to test an application against the main dataset. So normally without doing a full copy of the dataset, there is a very risky proposition because the test setup can corrupt and it can overwrite the production data. So admin should need to create and read-write snapshot on the production dataset, and they should assign the read-write snapshot to the user that could be utilized for experiment. So changes that needs to be done to the read-write snapshot that will not be reflected on the production dataset. And number 4 would be for disaster recovery purpose. So here, suppose read-only snapshots can be created and it could be utilized to create a consistent point-in-time image for application, and that one can be utilized to copy it over the remote site for disaster recovery. And typically for HDFS real-time clustering, there are some high-level requirements for read-only snapshot, read-write snapshot, support for taking snapshots for the entire namespace or a subtree. There is a support for reasonable numbers of snapshots in a single name node, and there is a snapshot that should be easy enough to browse through the standard commands and tools. So for read-only snapshot, that's for RO snapshot, which you typically go for. So RO snapshots are the immutable copies of underlying elements of the file systems. Read-write snapshot are typically utilized for the, it can be modified by the users, of course, for support for taking snapshots of the entire namespaces or the subtree itself, and it has got support for a reasonable numbers of snapshots in the single name node. And snapshots should be very easy to browse through the standard commands and tools, and for copying of the data from a snapshot should work with the standard Hadoop commands and API. So there are two considerations, like for high-level approaches. Number one option, it could be for taking up the snapshot, both the data node and name node that could be aware of the snapshots, and they should save the state internally about the snapshots. So data node is aware of the fact that some of the blocks are for the snapshot files. And option 2, that one could be only name node should be aware of the snapshot. Data node would not be aware of the fact that some of the blocks are owned by the snapshots of the original file. So if option 2 has been selected to keep the in the designing simple, so additionally taking snapshot is very fast with the last option, that is option 2. So data node would not know anything about the snapshot, what name node would be airing off, and it should not be aware of the block ownership issues between the root file system and the snapshots. So keeping data nodes free from any snapshot information, it could simplify the design immensely by eliminating the need for distributed coordination from the design of the snapshot by restricting the changes to the name node only. Now, a key requirement is to ensure that there could be a very easy steps, that's to create and delete the snapshot. Snapshot creation and deletion is a typically admin-only capability. To create a snapshot, one should specify a snapshot name, a path to the root of the subtree where snapshot needs to be taken, and whether or not the snapshot is read-only or read-write, that property that needs to be defined. So in a case, suppose a user admin needs to delete a snapshot, it should record just a snapshot name. That's all. A command that's to list all the snapshot, that could be like accessing directories or files in the snapshot. So snapshot, that it should be referenced with a regular HDFS file names with reverse string like HDFS. Suppose I'm working with Hortonworks Sandbox. Port number slash path of snapshot slash dot snapshot name, just need to mention the name, and rest of path in snapshot. Rest of path of the snapshot. So if we write this commands like this for accessing the directories and files in the snapshot, so this has got the benefit of that snapshot could be referenced along with all the existing Hadoop commands and APIs that could take a path name by adding a reserved snapshot string to this path name. So suppose if I'm having a file in my HDFS, like I want to make use of it, Hadoop FS for Hortonworks or HDFS DFS for Apache Hadoop, -a-b slash, I have some snapshot file, snapshot HDFS 1 slash c slash foo.txt. So in order to copy this file from temp slash foo/foo1.txt in snapshot branch to foo bar, so we need to write Hadoop fs cp snapshot HDFS 1 slash c slash foo.txt slash foo bar. So some of the caveats that for read-only snapshot, that could include the fact that read-only snapshots is immutable. So operations such as creating a new file, deleting a file, creating a new directory, renaming a file or directory, that will fail when execution is being happening on the snapshot branch. So typically snapshots are a pretty much useful feature to have in a mature file system, and this is typically a work in progress, and we could have a full functional prototype that could be implemented. The first versions of the feature that in Hortonworks, they would support the read-only snapshots only. The support for read-write snapshots, that will be added, it's already being added in the HTTP 2.2 onwards, and there are some several features that they have already incorporated into snapshots, such as time to leave TTL for snapshots that could be come up with auto deletion, schedule based creations of snapshots, making specific directories as snapshots worthy, quota based restrictions or space that could be utilized with read write snapshots, and delegations of authority for creating or deleting snapshots at the specific locations of users. So these are the specific features that's still available. And for example, it's still starting. So in the demo, suppose for an example scenario, I could take up some sample data that I could add into the HDFS on a daily basis for processing and for long-term storage purpose. And suppose I have been working on web server logs data that could be storing permanent basis day by day in my cluster, and these logs are being loaded in few times in a day. and the data set that could be organized into the specific directories that could hold the log files per day in HDFS. So since the web server logs are being stored typically in HDFS, so it could be imperative that they need to be protected from deletion as well. So if I could consider, like I have some data like this, data web logs, and I have some set of data web logs. Like this way, I have some data. So in order to provide the data protections and recovery for the web server log data, so we need to enable the snapshot. So snapshot should be enabled for the parent directory. So we need to add this command then, HDFS DFS admin. The parameter would be allow snapshot /data/weblogs. So whenever we execute this following command, that HDFS DFS admin allow snapshot, so it could be the snapshot capability would be, first of all, it would be enabled in the HDFS, and it would be able to provide the data protections and recovery for the entire data, that where the snapshots would be enabled on the directory. Snapshots need to be explicitly enabled for directories, and this provides the system admins with the levels of granular control that they need to manage the data in Hortonworks cluster. And if you just take a point in time for snapshots, so suppose the next command, whatever I'm writing, it would create a point in the time snapshots of the data weblogs directory and its subtree. So the command would be create snapshot /data/weblogs. So it will create a snapshot and it will give a default name which matches the timestamp at which the snapshot would be created. Users can provide the optional snapshot name instead of the default one, and with the default name, the created snapshot that could be like this. This types of name would be created like data weblog /.snapshot, like this. Snapshot / some GUID value. Which time the log has been taken up, so that one. So users could schedule a cron job to create a snapshot at the regular intervals. Now next, in order to view the state of the directory at the recently created snapshot, so next we just need to write Hadoop FS less data weblogs snapshot, the name of the file, that one. So this command could be utilized to view the state of the directory of the created snapshot. So it could show us all the snapshots that has been created over the point of time, over the all of the sample data set. Like in this way, if I have the data correspondingly for all of the other days, or typically for the same day, I have different data, weblog data on the different times. So all the files could be available. Now, if you want to recover the lost data, so suppose a new data has been loaded into the weblogs dataset, and there could be some erroneous deletion has been happened of a file or the directory. So suppose an application could delete the set of the logs pertaining to the September 2nd, 2014 that being stored within the this directory, data weblog /2014 2nd September directory. Now here, since data/weblogs has a snapshot already, so the snapshot would protect from the file blocks being removed from the file system. So a deletion will only modify the metadata to remove this directory, the following directory, from the working directory. So to recover from deletion, data needs to be stored by copying the needed data from the snapshot. So in that case, you just need to copy it /data/weblogs. You just need to copy it back to the snapshot from the snapshot path to the actual path where it has been deleted. So it will also restore the lost set of files, that is to the working data set. So you just can have a look on this. So you'll be able to see that the deleted file has been came back. So since the snapshots all are read-only snapshots, so HDFS will also protect against the user or application deletion of the snapshot data itself. So the following command will fail if we are trying to do this. HDFS DFS RMDIR, suppose data weblog snapshots is 2014 410 3001 2014 0401. So in that cases, if you are trying to delete this directory completely, so HDFS will protect against the user application deletions of the snapshot data. So these operations, if you're trying to perform, it would be failed. So typically, with the Hortonworks clusters itself, it's being enabled. We can utilize snapshot to protect the enterprise data against the accidental deletion, corruptions, or errors. So normally in the normal cases, that could be possible. So that was all about HDFS snapshots and enterprise data backup on Hadoop clusters with HDFS. So tomorrow, what we will do, tomorrow we would go work on specifically on the hands-on side on configurations of name node for automatic failover. We would check up the specific configuration steps for configuring name node high availability and name node automatic failover status, some specific name node commands, HA admin commands, and also we would check up the Kerberos security, how to set up a secure HTTP cluster. So that could be needed for the purpose. And if any cases, like if any specific modules is being there left, just let me know. You guys can let me know. And otherwise, that is pretty much we have. And if possible, we will check up a demo on incremental backup of data from HTTP to any cloud platform using Apache Falcon for Hadoop cluster disaster recovery and bursting capability. So that's a pretty good hands-on on that and a good demo. So if after completions of all the specific modules, required modules, if time persists, so I would go ahead and would configure on the demo itself. So that's all for today, guys, and can let me know if you have any specific questions or concerns, or in that case we would meet again tomorrow.
Thank you, Anita. Let's meet tomorrow.
Okay. Thanks everyone. Have a nice day.